Here's question 2 from the June paper you just did. So we start with a quadratic and we have to complete the square with just integers. Okay, so because we haven't got x squared on its own, we've got a coefficient of 5, we're going to start by just taking that coefficient 5 outside the brackets and see what we've got left. So we have x squared minus 4x. Now I could take it out and have plus 3/5, but that makes a fraction, that's a pain. So I'm just going to end my brackets there and put a plus 3 on the end. Okay. Now we can complete the square for the expression inside the brackets. So remember, we take x and then we're going to half the coefficient of x there. Then we put end of brackets and squared. Then we need to subtract the square of the number in the brackets. Okay, that completes x squared minus 4x, and then, so I've ended the brackets, then I've got plus 3. Okay, so let's do a bit of tidying. So we've got 5 multiplied by x minus 2 squared and 5 multiplied by negative 2 squared, so that's negative 4. So that gives me minus 20 plus 3. And finally we get 5 brackets x minus 2 squared, and this will make take away 17. Okay, we've got 3 integers and it's in the format required. Okay, so p is 5, q is negative 2, and r is negative 17. Let's look at b. State the coordinates of the minimum point on the curve. Okay, y equals this. So we're going to get our smallest possible value when this bracket is 0, because anything squared will be positive or 0. So when that bracket's 0, the x coordinate is 2, and if that is 0, y will be, y equals this, so we'll have 0 take away 17. So our minimum is at negative 17. Okay. For the third part, state the equation of the normal to the curve y equals this quadratic at its minimum point. So there's a lot going on there. It mentions a normal, so I'm going to sketch what's happening. So we know that this is a happy face quadratic because we've got a positive coefficient of x squared. We know that the minimum value is at 2, negative 17. And remember, a normal is perpendicular to a tangent, so I'm going to sketch the tangent, which will be horizontal at that minimum point, and so the normal is the vertical line running through that minimum point. So the vertical line always has an equation x equals a number, and it's going through where x is 2. So that means our equation of our normal is x equals 2. And that's it.